Okay, so in a problem like this, where we're just given the two angles and no dimensions, there are formulas in the packet that you can use to find the angles without having to do anything else. But again, those are formulas you'd have to memorize, and I want you to be able to find the right triangles and figure them out without having to memorize stuff, because let's face it, a year from now, you're not going to remember these formulas. So looking at this, the way I would handle it is I would just pick a dimension here and use that dimension. Now, we're not finding any length of cut or anything here, so it really doesn't matter what we use. So I'm just going to pick something easy to use, like 10 millimeters. So then from that,
you're just supposed to pick a number.
Just pick a number, yep. Since there are no numbers there, just pick one for a depth and use it.
Then how do you know if it's right? Like when you check it, how did you get the right answer?
Well, the weird thing about it when you're dealing with angles is one dimension, if you pick one dimension, all the other dimensions have to be proportional to it because of the angles. So this dimension isn't necessarily correct, but the relationship between the other dimensions will be the same because of the angles. And let's go through, we'll use the 10 millimeters, then I'll go through and I'll take the formulas out of the packet, and I'll show you that you come up with the same answer. Yeah, the biggest thing is once you pick one dimension, all it does is makes the whole thing bigger or smaller, but the angles, the relationship between the angles doesn't change. I know it seems weird to just pick a dimension out of thin air and use it, but since we know the angles, everything else works out. So let's find, I'm going to call this one X and this one Y here. To find X, this is 19, this is the opposite, this is the adjacent side. There's my right angle. So we're dealing with a tangent of 19 degrees equals 10 over X. So we can put in the 1 there, and we can cross multiply and divide. 1 times 10 is 10. 10 divided by the tangent of 19 is 29.04. So 29.04 millimeters there. Over here, we're going to do the same thing. Here's my right angle. We have the opposite and the adjacent sides. So tangent of 26 degrees equals 10 over y. So once again, I'll put that over 1, and I'll cross multiply and divide. So 1 times 10 is 10, divided by the tangent of 26 degrees. All right, 20.50. Now again, these dimensions here that I found are not really the dimensions that are up here. We found these dimensions here. Those aren't really those dimensions, but the ratio between those dimensions and this dimension is the same because the angle determines the ratio in the dimensions. Any questions as how I found these two numbers right here? Okay, now from there, we find the angle of rotation. Now the angle of rotation is actually this angle up here on top, but it's the same as this angle over here. So if I look at this from the top view, with this cut going across here, remember we're taking this up into here at a right angle. That's this top blue line up here. This is our angle of rotation, but it'll be the same as this angle here. This angle right here that I just labeled R is found by the ratio of these two dimensions. This dimension is what we just found to be 29.04. And this is the one we just found to be 20.50. R then, again we're looking at opposite and adjacent, but we're looking for an angle, so it's going to be an inverse tangent of the 29.04 over 20.50. giving us 54.78 degrees. So R here is 54.78 degrees. So that's our angle of rotation. To find our angle of tilt, the angle of tilt is this angle right here. And that's this kind of a point of view, and that's a little bit tough. Here's the right angle we're looking at. So if I pull that triangle out, it looks like this. This top piece here is this piece that goes across here. So we have to find that length yet. This piece here is this part right there. That's just this dimension, the one that we picked to begin with, 10 millimeters. Here's my angle of tilt. So I have to figure out this top dimension from this figure down here. So what I'm looking at is this triangle here with that right angle. I know that this angle here is the same as the one we found up here, the 54.78. And this side here we found to be 29.04. So that means this side is the one we're looking for, is the adjacent side to our angle, and we have the hypotenuse, so we're dealing with a cosine. A 54.78 degrees is going to be that dimension, I'll call it A, over 29.04. So we make that over 1, or cross multiply and divide. So cosine of 54.78 times 29.04 divided by 1, 16.75. So that means this is 16.75. So then T, we have opposite and adjacent sides. So we're going to inverse tangent of 10 over 16.75. .84 degrees. So my angle of rotation is 54.78. My angle of tilt is 30.84 degrees. Now in the packet, they gave us some kind of ugly formulas, tough to remember. Let's take a look at those. I gotta find where they put them. Okay. They're giving us that R. I'm looking on page 408 of the packet. To find R, it's telling us that the tangent of R, of angle R, is equal to the tangent of B over the tangent of A. Now up here, this would be considered angle A, the 19, and this would be considered angle B, the 26. So what that's really telling us is R is the inverse tangent of the tangent of 26 degrees over the tangent of 19 degrees. I just did the inverse tangent to get rid of the tangent over here. So second tangent 26, make sure I close that parentheses, divided by the tangent of 19, and I have to close the parentheses twice, I get 54.78 degrees, which is exactly what we got up here. T, they're telling us for angle T that the tangent of angle T is equal to the tangent of the angle A over the cosine of angle R. So you have to know R in order to find T. So that means T is equal to the inverse tangent of the tangent of A was 19 degrees over the cosine of R, which is the 54.78. So second tangent of tangent 19, close parentheses, divided by cosine 54.78. We have to close parentheses twice. 30.84 degrees. Which is, again, what we had up here. And I do realize those formulas are a lot easier, but in practice, like I said, a couple weeks from now, you're not going to remember those formulas. But I wanted to show you the long way around of, if you know how to use the right triangle trig, you can figure out the angles without having to memorize the formulas. If for our quizzes and tests, if you want to memorize those formulas for this problem, that's fine by me. But like I said, it's better off for you in the long run to be able to find the triangles and work it out the long way. Yep, similar problem right here. So I want you to find the angle of rotation and the angle of tilt. Find those in your notes. Okay, so if we were using the formulas, R is equal to the inverse tangent of B would be 29 degrees over tangent of A, which is 21 degrees. So second tangent, 21, close, divided by tangent 29, close and close. I get something wrong. Wish it my second didn't take. Second tangent, 34.70 degrees. So what you guys got? You did 29. Oh, I did A over B. It's supposed to be B over A. It should be 29. Yep, I did that backwards. Yep. Second tangent should be 29 first. I wrote it down right, but then I punched it in wrong. 55.30. Sound better? See, it's always got to be this angle is B over this angle is A. So I wrote it down as 29 over 21, then I punched in 21 over 29. You can always tell the difference because there'll be complements. Because 34.70 is the complement of 55.30. Then for t is going to be the inverse tangent of the tangent of A, 21 degrees, over the cosine of R, the 55.30 degrees. So second tangent, 21 close divided by cosine 55.30. Close and close. 33.99 degrees. Okay. Now again, if you're doing it out the long way, all you have to do, like I said, you can pick whatever dimension you want there for the height. I always use something simple like 10 millimeters. And from that, using those angles, you can use tangent to find this dimension and this dimension. And of course, this dimension is that dimension. So what you found is this side and that side. And you guessed, you just assumed that side. Once you have those three dimensions, this is just like we did before. You're finding the corners of a box, basically. Any questions? How many of you have actually had a lot of time to do these problems in the packets? Some of them? Yep. They had some of them that are cut off a different corner. Yeah. Yeah, like 6 on page 410. Mm-hmm. And what you need to do is just rotate the block. Like on page 410, they're number 6. They've got the top view drawn with this corner cut off instead of this one. And unfortunately, they've got the picture wrong. Actually, they don't have the picture wrong. They've got it like this. They've got this drawn here that this is 41 degrees, 30 minutes. They've got it drawn with a dotted line here. Have you guys gone over what that dotted line means on a print? It's hidden. You're looking through the object to see that surface. What I would do with this one, to be honest, is I would rotate it. So what I've done is I've rotated this a quarter turn. So I move this corner over to here. So now this becomes this side view, 41 degrees, 30 minutes. 30 minutes, not seconds. And this now we're looking at it from the other side. So it's coming through and this is 46 degrees. And now it's very clear what's angle A and what's angle B. And that's usually the easiest way to handle these is to rotate them. So that's number 6 on page 410. Number 7, they did a similar thing. They're giving you this backside, the angle's on the backside here. Or the cut is on the backside here. So both of them are hidden angles. So this is 37 degrees here. This one's giving us 48 degrees. Well, here I would rotate this a full 180 degrees, which would bring this corner down to here. Like that. I'll do that for you. So now this here is going to be which angle, the 37 or the 48? I should have drawn these as dotted lines, by the way. Well, This side is now here, right? So what I was viewing here through the object, I'm now viewing here as the front of the object. So this is the 37 degrees here. This end view here would be the 48. So that's one of the keys to these is you have to be able to rotate them to get them into position if you want to use those formulas. So then of course this is angle A and this is angle B. But those formulas only work if you have this lower right corner as being the corner that's being machined off. So you've got to be able to rotate the parts. Any questions? Okay, for homework today, I want you to continue working on that on page 410 and 410 through 412, I believe. 410 and 411. And going back into the previous packet, looking at the drilling, if there's problems there that you haven't finished, go back and review those. By the end of this week, we probably will finish this compound angle stuff. I will not be here Thursday. I'm going to be in New Richmond doing interviews for a position we're trying to fill. And I got picked to be. Well, it's a district-wide position. So it's
WITC.
for WITC, yes. Yeah, I'm not interviewing. I am on the interview committee. I'm not applying. I'm looking at helping hire the person. I'm not trying to be the person hired. Yeah. I get to ask the questions for this one. Yeah. So this Thursday I will not be here. Most likely what's going to happen is
I thought you said you're not the interviewer.
I'm not the interviewee. I'm not interviewing. I'm the interviewer.
I thought you said you're not the interviewer, but you're on the interview
Oh, no.
committee. I'm like, hold on, what does that mean?
No, I'm not interviewing. I'm on the interview committee. Okay.